Hey guys, today we've got angle relationships in triangles, our EQ. What are some theorems about the measures of angles in triangles? Our learning goal: find the measures of interior and exterior angles of triangles and apply theorems about the interior and exterior angles of triangles. We're going to talk about the auxiliary line, a corollary, interior, interior angles, exterior angles, and remote interior angles. First thing, we already know this. You don't have to write down the sum theorem. The interior angles of a triangle have a sum of how many degrees? That should be in unison. Guys, the angles of a triangle add up to be how many degrees?
180.
180. It's a maxim. It's a thing that you have to know in here, which you do already, because we'll say it just about every day for a while. Okay? The angles of a triangle have a sum of 180, always and forever. Okay? You might want to write down auxiliary line, okay? Because probably something new to you. An auxiliary line is just a line that is added to a figure to aid and approve. It is not part of the triangle. You hear me? It is not part of the triangle. It's just used to help the viewer or the student out when we talk about aspects of the triangle. Okay? So for example here, if we talk about angle 5, we could say, hey, the remote interior angles of 5 are 1 and 3. We'll get into that later today. Or we could look at this auxiliary line and we could say, hey, 4 plus 2 plus 5 has to equal 180. Perfect. Okay? Or if I made these parallel to each other, I could say angle 1 and what angle are congruent through alternate interior angle theorem. Here's a hint. It's between 3 and 5.
4.
Wow, guys. Yeah, there you go. Right? Okay. 1 and 4 would be congruent if those are parallel because they would be alternate interior angles. All right? So, we will have that thing called the auxiliary line from time to time.
Like an auxiliary.
Anybody still need it? Cool. Alright, probably none of you can see this particular drawing, so in first block I was asked if I could turn the lights out, and it worked for about 3 seconds, and then some kid went to sleep, so don't fall asleep. Alright, so, okay, check it out here. I want to find the measure of MJK. Angle MJK. So I'm trying to find that angle measurement raw star. Okay? I've got to use my triangle sum theorem to get this information. First bit of information.
That's 90 degrees.
I need to find the measure of this particular angle. I've been given 88 and 48. How can I find that angle measurement? Subtract 88 and 48 from 180. You should be on your calculator right now,
44.
letting me know that 44 is the correct answer. Okay, so this angle's 44. Robinson, you did a great job yesterday. This angle's 44, and it has that little line with it. And there's that little line too. What do those little lines mean? That they're the same. Say the C word. What's the big C word in here? Congruent, right? Those angles are congruent. If that one's 44 degrees, this one has to be 44 degrees. Okay? Got me? And now we get to play the game all over again. What game are you talking about? The triangle sum theorem game again, right? Guys, I got 3 measures of a triangle. I need to find the missing angle. How am I going to find it? Okay, 180 minus 104 and 44. Y'all see this? 104 and 44, I believe it's 32, correct?
Yes.
Okay, so the measure of MJK is 32. Do you see how just that one theorem is very helpful, right? Everybody with me on that? That single theorem can give you a lot of help in here, okay? And I mean, like today when you learn it, you don't ever forget it because it's going to come back again and again and again. You with me? Any questions on that? So when I tell you, hey guys, there's 3 angles in a triangle, they have to have a sum of 180, right? Okay? It's probably the most important number we'll have in here, 180. Alright, go ahead and write down some corollaries, and then also write down a little bit of that chart below it. Oh.
Can you let
So-
me get the front light off?
Corollary is a theorem. Corollary is a theorem whose proof follows directly from another theorem. So I gave you 2 corollaries to our angle or triangle sum theorem. Okay? Corollary numero uno. That's 1 for those of you that don't speak Spanish. The acute angles of a right triangle are complementary. Corollary numero dos. The measure of each angle of an equiangular triangle is 60 degrees. Let's talk about this first corollary. The 2 angles of a right triangle are complementary. Oh, perfect. Miss Morris, tell me what complementary means. Sum of 90. Good, I can't even make sense. Alright, so why would it be true that the acute angles of a right triangle are always complementary? What is always in a right triangle? A 90-degree angle, correct? How many degrees are in every triangle? So if every single right triangle has 90 degrees in them, I'm sorry, if every single right triangle has a right angle in it, correct? And every triangle has 180 degrees in it, the non-right angles of a right triangle always have to have a sum of 90 degrees. See? See why we call that a complementary angle or complements? Okay? Do what? 45, what?
The answer is 45.
D and E are 45. Doesn't have to be. Could be, could be 46 and 44. Could be 40 and 50. Could be 1 and a 79. Yeah, we'll get into it. Don't worry, we have a whole unit on right triangles. It'll answer all your questions. If these side lengths are equal, then they have to be 45. If those angles are equal, it has to be 45. There's so many. I can't wait for trigonometry, okay? But we'll wait just a few weeks on it. All right, the measure of each angle of an equiangular triangle is 60 degrees. Bonus points to somebody who can explain why that's true. This bottom one. Yes, sir. Right here first.
Since you have like grades, all the angles A, B, and C are equal.
At the what?
They're equal 20, they're equal 60.
Okay.
You don't have to be
Miss Cobalt. Correct. Equiangular means that they're all equal angles. Okay. You're halfway there. To what?
That's the only way it can be equal.
Okay. You're right. There's a key part that you're not saying, but let me see how we got here. Same thing. All right. Hey, what would 180 degrees have to do with this? Well, say it, Angel. Say it louder. Guys, all the angles have to be equal. All the angles have to have a sum of 180. Guess what 180 divided by 3 is? 60. Okay? So that's why I was saying there's one part you're missing, all right? 60 degrees in each particular equiangular triangle. There's 60 degrees in each angle. Clear on that? Okay? Coincidentally, what would we call this kind of triangle? Say what? It's called an equiangular or equilateral triangle. Alright? Let me. Okay. Don't worry. No, just wait. Let's just see if common sense will prevail here. Okay? I'm gonna pick on somebody who I don't think is paying attention to me. All of you are paying attention. Baloo, you'll do. Alright, so Jamie, tell me what angles do you think are inside the triangle?
1, 2, 3.
That's what interior means, right? Everybody with me? Interior. The set of points inside the figure, inside of the triangle. Jamie, what do you think the exterior point would be? 4, because it's where? Outside. So don't write it down because you already know it, right? This is called common sense, everybody. Interior means inside, exterior means outside, right? And even if I add a bunch of funny words to it, guess what it still means? Inside and outside. Scarborough. An interior angle is where in relation to the triangle? What are the interior angles of this triangle? An exterior angle is where in relation to the triangle? What is the exterior angle? Wow. Y'all see that? Everybody with me? Okay? So you don't, we don't need to like have the written definition. You just use your brain that God gave you and you'll be fine on that, right? Interior is inside, exterior is outside, don't worry about the rest. The only part of the rest that we have to worry about is this slide. Okay? So each exterior angle has 2 remote interior angles. Alright, we'll worry about it. A remote interior angle is an interior angle that is not adjacent to the exterior angle. Okay, what the heck? Alright, so there's a little bit, I promise in 5 minutes this will all make perfect sense to you. We're going to add just a little bit more to this drawing. First thing we're going to add is an auxiliary line with angle 5 out here. Then we're going to add an auxiliary line with angle 6 up here. Finally, I want you to create a chart. Angle 4, angle 5, angle 6, and then these are going to be called the remote interior angles. Okay, remote interior angles. So I want you to write this whole slide down, draw the diagram or it won't make no sense to you, and create this chart. We're going to add, so remote interior angles are the 2 angles that are not adjacent to exterior angles. Really weird definition, very simple application. Alright, a remote interior, let me take a step back. What does adjacent mean? Who's sitting adjacent to you?
You.
And who? Nope, he's sitting behind you. Yep. And how would you describe that if your mom walked in the room? You'd say left or right or what else? Right side or what else? Legit? You would say, probably say sitting next to you, right? Right next to him, okay? Alright, so here's the deal. To find remote interior angles, this is the process you'll use. Pick an exterior angle. Determine which angle is next to it, and don't use that one. Use the other 2. Blue. You want an angle 6. What angle is next to 6?
2.
So what are the remote interior angles?
1.
1 and 3. 1 and 3 are the remote interior angles to 6. Stephanie, pick an angle between 4 and 6. Do what? 5. What angle is next to 5? 1. What are the other 2 angles? So 2 and 3 are the remote interior angles to angle 5. Oh, Brianna, pick the remaining exterior angle that I haven't filled out in my chart. I'll help you out. Pick the exterior angle that's between 3 and 5.
Which one?
It's 1? You think one's exterior?
You said between 3 and 5, so.
There's only one option, and it's not one. What is it, Miller? 4. What angle inside the triangle is right next to angle 4?
30,
So what are the remote interior angles to angle 4?
30, and 4.
Ah!
2 and 1.
Gotta quit texting, right? 1 and 2. If you just fill out this chart, you probably ain't gonna figure it out on your own, right? You gotta go through that process. What angle's next to it? What are the other two interior angles, inside angles of the triangle? It's all important for the following reason. Okay? Bam! The measure of an exterior angle is equal to the sum of the measure of its remote interior angles. Write down the theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles.
I'm not doing anything.
Oh, good. So if I wanted to find the measure of angle 4, okay? If I wanted to find the measure of angle 4, I got one of two ways I can do it. You could, in theory, take 180 minus angle 3 and you'd get angle 4. We'll worry about that later. That's called a linear pair, right? 3 and 4. They're on the same line, aren't they? Yeah, they are. Hot dog. Check it out. Angle 1 plus angle 2 equals angle 4. I need a more substantive example, Mr. Hobbs. No problem. 60 degrees, 45 degrees. What's the measure of angle 4? First one to it is the, do what? 105. 60 plus 45 equals 105. So that's the same thing as saying angle 1 plus angle 2 equals angle 4. Angle 4 would be 105. Last thing that we got for today is this. Two angles of one triangle are congruent to two angles of another triangle. Then the third pair of angles are congruent. Basically, this is the pick two, get one free, right? Buy two, get one free. Whatever. All right. Hey, check it out. If you can get two angles, two different angles in two different triangles congruent, the third angles have to be congruent. Why is that true? 180 minus 180 minus 50 and 25 is always going to be the same, no matter which particular triangle you're looking at, okay? I just made those numbers up, right? If it's 50 here, it's got to be 50 there. If it's 25 here, it's got to be 25 there. All right, I'll let you come back. All right, here we go. The measure of one of the acute angles, don't write it down, let's just solve it. The measure of one of the acute angles of a right triangle is 63.7 degrees. What is the measure of the other acute angle? Hey, Miss Morris, it's a right triangle. So the acute angles are what? Smaller than 90, that's a good answer. Yes, they are. What word do we say that describes those angles that are smaller than 90 and have a sum of 90? Complementary. Complementary, right? Guys, all you got to do to figure this problem out is simple subtraction. It's a right triangle. So the non-right angles are complementary. 90 minus 63.7 will always give you your answer. What you got? Check out this. Do it for the class, okay? Let's say you don't believe me. There's not the trust that's established yet. How many degrees are inside every triangle? So take 180, subtract out 90, and then subtract out 63.7. Now do you believe me? 26.3, right? Same answer. You got me? Okay? So right, we'll do right triangle we'll do right triangle, we'll do a whole unit on it. It's by far the worst few weeks of your life. But it's okay, alright? I mean, it's a good time for me. Alright, so find the measure of angle ACD. What's the first thing you notice about ACD?
It's a
Not a right angle? Do what?
exterior
Exterior! Perfect, Baloo. It's exterior. Why is that helpful for me? What theorem would come into play?
Exterior.
Yeah, we call it the remote interior angle theorem, but it's okay. You can call it the exterior angle theorem. All right? So check it out. The remote interior angle theorem says this exterior angle equals the sum of its remote interior angles. You don't have to memorize that at all. You just got to know what it means. And it's all about that word adjacent. What interior angle is adjacent to this angle? Yeah, right here, correct? So that means I leave that one alone. I don't worry about it. I focus on adding these two angles together. What does the box make?
90.
So that's 90 degrees plus 2z plus 1 equals 6z minus 9. You got me? Okay? If it seems incredibly ridiculously simple, it is. It really is. You just have to make sure you're not setting them congruent, right? Guys, this is not, this is, the congruency comes after you take the sum. A lot of people are just going to put 90 equals 6z minus 9. Okay? And that is a valiant effort. You're completely wrong. But it's a valiant effort. Okay? Some people put 2z plus 1 equals 6z minus 9. Once again, valiant effort. Completely wrong. But good job for trying. Okay? The winners put 90 plus 6z minus 2z plus 1. The winners get it right. The winners put 90 plus 2z plus 1 equals 6z minus 9. We call these multi-step equations. You can do them on your own now, right? If you can't, you're in the wrong class. All right, guys? Nope. Algebra rules haven't changed overnight. All right? Everybody look. Solve for z, plug it in, you'll have your angle measure. Then it gets real. Okay, how many triangles here? No, I got 3, but, you know, 2 will work, alright? Hey, I got 2 that I'm worried about. Triangle FKH and triangle IJG. The keen observer notices they have how many angle degrees in common? 2 pair, correct? G and H are in common, F and I are in common. The third angles have to be what? Congruent. So 4y squared has to equal 6y squared minus 40. I will not do that problem with you right now. Trust me, it exists. You know what? I'm going to. We got time. We got plenty of time, actually. It's important that I do this at least once, mainly so that I can say I did it at least once. No, I'm just kidding. Mainly so that you guys don't forget your rules, your reverse PEMDAS rules. Reverse PEMDAS rules, right? This one's a little different, okay? This one's just a little bit different for me. All right, I'm going to show you how I would do this one. I avoid the negative numbers. Y'all hear me? I want to avoid the negative numbers. So actually, the way I would do this, I would add 40 to both sides to get 4y squared plus 40 equals 6y squared, and then I would subtract 4y squared from both sides. Okay? You don't have to do it that way, but to me, that's the simplest way. OMG. I've got 2y squared equals 40. How do I solve for y? First thing I do is divide both sides by 2. Which 2 does that get rid of? The what? Yeah, guy in front of the y called the leading coefficient. It's all good, okay? What is 40 divided by 2? 20. All right, let's see what we remembered. If you'll remember what gives me a heart attack and what doesn't. Mr. Vo. Mr. Vo. I've got 20 equals y squared. How do I solve for y?
You did. What? That don't make any sense.
20 equals y squared. How do I solve for y? Only Mr. Vo.
Problem you just did.
I'm not done yet, Mr. Vo. 20 equals y squared.
How did you square?
Divide.
Square.
What do you do, Vo?
Your y.
No! No! I don't have any hair left, Vo. This is the reason I don't have any hair. How many times are we gonna? So when I get to this point, how do I get rid of the exponent? Y. Take the square root of both sides. Okay. Oh, let's see how much that really costs you. Square root of 20 equals y. I like that simplified radical form. Oh, I want this. I want Big Dog to tell me. You remember how to do this, Big Dog? No? And they ask me all the time, do you ever teach algebra? Yeah, every day. What's the highest perfect square that's a great, what is the highest available perfect square that's a factor of 20?
5.
No, 5 is not a perfect square. 4 is definitely the perfect square. You wanna know how I do this? 20 and 1, 10 and 2, 3 and nothing, 4 and 5. Which one of those is a perfect square? 4. What else? Anybody?
22.
1. Okay. So here's my perfect squares. Watch how I do this. Take the square root of both of them. What's the square root of 4? What is the square root of 5? No, we don't put it in decimal form. Remember, that's the whole point of simplified radical form. If it doesn't have a square root, we leave it as is. I didn't even get my answer, right? I'd have to plug that in to my answer. So are we good now? On not just texting in class, but also on how to get rid of squares. What do we get rid of exponents with, Matt? What do we call them?
Forgot. Is it radical? No.
That's you can call it radicals, roots. Don't call it roots, okay? Any questions on that? Sudden, are you all right? You should be in my shoes and have to do that multiple times in your life.